All right, guys, let's go. So, question one, we're told to sketch. So, how do we sketch this graph? So, depending on how you sketch your graph. So, the way I normally recommend doing this is to just sketch the original graph. Y is equals to x plus 3a. So, when x is 0, y is 3a. When y is 0, this is so when y is 0, we have x as minus 3a. So minus 3a is there. All right, so what do we do next? So we just make our lines. So normally when x is 0, remember this is the x-axis, this is the y-axis. When x is 0, y is 3a. So this is 3a. Then when y is 0, x is minus 3a. This is minus 3a. Okay, minus 3a. Now, minus 3a will be somewhere here. So this line actually goes like this, right? But I don't need that line. So I need it to come here and be a V on this side. So this is minus 3a. So that is my modulus. That is the graph they want me to draw. Now for B, we need to solve this. Now, when there's modulus on one side, I always recommend doing plus minus, remove the modulus and just keep plus minus on one side. So this is plus minus x plus 3a equals greater than a minus 2x. Okay, so we have, I'm doing the plus one, so x plus 3a greater than a minus 2x. So this will be 2a is equals to minus 3x. So greater than minus 3x. Okay, I'll just move it to this side. I think it's better to move. So this is 3x is greater than minus 2a. So x is greater than minus 2a over 3. So this is one answer. Now, if we solve the other one, it becomes minus x. I'm just expanding with the minus 3a is greater than a minus 2x, right? So I can collect like terms. So this would be x is greater than 4a. All right. So now, which of the answers do I take? Now this is, so the best way to know, you can easily sketch a minus 2x. So let's say we want to sketch this. So when x is 0, y is a. When y is 0, okay, so y is equal to 0, then you have 2, so x will be a by 2. So this has a negative gradient. So when x is 0, y is a. So y is a, so up here, let's say here. Okay, let's put it down here. Then, so when y is 0x, so this line is actually like this, something like this. So I only have one point of intersection because minus 4a, there's no way to intersect on this side. So my only point of intersection is this. So this is my answer. It will not intersect at, anyway, negative is, see the negative is on the left. So, and we have minus 4a. So my answer is only this one. This is not my answer. I hope that's clear. Okay, now let's see question 2. So for question 2, I can see some indices first because I don't want to make it complicated. So I will try to bring the indices, make indices. So I'll just do 2 to the power of x plus 1 divided by, bringing 4 Then I'm leaving 3 to the power of 2x minus 3 and dividing by 3. So I'm just, so if you cross multiply, you get the same thing. So note that this is 2 to the power of 2. So 2 to the power of x plus 1 minus 2 is equals to 3 to the power of 2x minus 3. This is 1 minus 1. So this will give me 2 to the power of x plus 1, x minus 1. X minus 1 is equals to 3 to the power of 2x minus 4. Now you see I can take log of both sides. So this will be x plus 1, x minus 1 log 2 is equals to 2x minus 4 log 3. Okay, now I can expand the bracket. So this will be x log 2 minus log 2 is equals to 2x log 3 minus 4 log 3. So I'll just bring the x to one side, so I can take this here and bring this here. So 4 log 3 minus log 2 is equal to 2x log 3 minus plus. So I'm taking this to this side. Okay, let me see what I'm doing. So I'm taking this, then I'm taking 2x, then minus x log 2 minus x log 2. Okay, so this will be 4 log 3 minus log 2 divided by, I just factorize x, so 2 log 3 minus log 2. Now let's check. So I should get, your calculator can solve this like I said. So my answer should be 2.46. They need it to 3 significant figure, right? So let's check if this actually gives me the answer. So fraction 4 log, okay, you can use ln, doesn't change anything. I don't know why there's no shift log. There should be log here. Okay, I can use ln. 4 ln 3, okay, minus ln 2, okay, divided by 2 ln 3 minus ln 2. Yeah, 2.46. So this is my answer. That is the perfect answer. So I hope you got this when you solved it. All right, so the next one we're looking at is complex number. So we're told to find the complex number represented by p. Okay, so we need to find the complex number represented by p. So I'll just go through the question to know. So obviously we need to go like this, then like this. So we know that is 2, so we need to find that point. So we know the center of the circle is 3, 1. This is the center, and the radius. So we can find the equation of the circle, then we can, so we need to find the line and the circle intersection. So the center is 3, 1. The radius is 2. You should know how to read that from this question. So this is always the radius. This is the center. Okay. All right. So x minus 3 squared plus y minus 1 squared is equals to 4. So r squared, 2 squared. So this gives me, so this is the equation of this circle. And this line x is equals to 2. So I put x as 2. So this will be 2 minus 3. So minus 1 squared. X is 2 because I need the point of intersection, plus y minus 1 squared is equal to 4. So from here, you can just solve that to give me y minus 1 squared is equals to 3. So y is equal to plus or minus square root of 3 plus 1. I hope that makes sense. So because my x is down, I need minus square root 3 plus 1. So my P will be, so I need to go 2 to the right. So OP will be 2 plus minus root 3 plus 1 I. So this is definitely my answer. I hope that makes a lot of sense. So we find the equation of the line and the circle, then we find the point of intersection. That is actually AS, but the main thing you should know, you can get the equation of the circle from there. Now we need to find the greatest value of arc Z. So from here, I need to find where that touches that. So I'm actually looking for this angle. So let's call that theta. So that's the angle I am actually looking for. So first of all, how do we find it? So always think before you start solving. So we can actually find here, then wherever it touches, you know that's a tangent. So this is 90. So, and we know we can find, so I'm just doing some working. So we can find this angle. Okay, let's call that alpha. And we can also find this angle because the radius is 2, right? So the radius is 2. And we can find the distance of O to the center. So O to the center, let me call this center C. Okay, I'll just call this center C. So OC, so you can see this is, look at the orange line, that's, you know, Pythagoras theorem. So OC will be square root of 3 squared plus 1 squared. So OC is square root of 10. So why am I doing that? So I need to find, so let's call this M. I would have not used M. So I need to find O, C, O, the angle CO, let me call this K. COK plus, so angle COK plus angle COM. COK plus COM. So that's what I'm finding. So COK will be tan inverse of, so you should know, you know that here is 1, right? This is 1. This is 3. They look. All right, so this is part C. So for part C, this is an easy question. So all you have to do is to start with x1. You can take the mid value of 0.4 and 0.6. So your x naught or x0 will be 0.5. Okay, so just press your calculator. So to find x1, you put 0.5 where there's x. So that will give you 0.48858. Then you press put this value and see what that gives you. This is 0.4883. X3 becomes 0.4947. X4 becomes 0.489. So to 4 decimal, calculate the roots correct to 2 decimal places. Give so my final answer will be 0. Give each result. So 49, I think 0, that will come. So my final answer will be 0.49 because all rounds up to 0.49. I would have used this calculator, but it's misbehaving. So you can use your calculator and check what you get. All right, let's see question 7. So question 7 is differentiation. So we are told to show that dy dx is this. So this is implicit differentiation. So we just differentiate. Whenever we differentiate y, we put dy dx. So if I differentiate, that becomes 6 y squared dy dx. So I use product rule for that. So hold this constant, 3x squared, differentiate y, I get dy dx, plus hold y constant, differentiate the other one, I get 6x, okay, then minus 3x squared, so 3x squared equal to 0. So from here I just expand and collect like terms. So this will be 6y squared dy dx minus 3x squared dy dx minus 6xy minus 3x squared equal to, so I just move this to the other side. So dy dx 6y squared minus 3x squared, so it's equal to 3x squared minus 6xy. So dy dx will be 3x squared minus 6xy over 6y squared minus 3x squared. So x squared, this is plus here, this is plus. All right, always check your work, and whenever they give you something to prove, you have to get that. So you just divide everything by 3. So that gives me dy dx will be equals to x squared plus 6xy over 6y squared minus 3x squared. So that so I am dividing everything by, why am I still writing that? So 2xy divided by 3y squared minus x squared divided by 3, here is 2. So this is 2. So 2, yes, so that's what we have. So I hope that's clear. Now let's see part B. Part B says, hence find the coordinates of the points on the curve at which the normal is parallel to the so we know that when it's parallel, dy dx is equal to 0. So that gives me x squared plus 2xy equal to 0. So the bottom will be equal to, so if I equate this to 0, so this cross multiply, so I only have the numerator. So x squared plus 2xy equal to 0, right? So from here, I can factorize x out. So x plus 2y So this means x is equal to 0 and x plus 2y equal to, so x is equal to minus 2y, or y is equal to x over minus 2. Same thing. Anyone you like, you can use to solve. So I will now solve. So when x is equal to 0, so I substitute back into my previous equation. So that's 2y cubed minus 3x squared y. So that's 2y cubed minus 3x squared y minus x cubed is equal to 16, right? I'll just check that again. Okay, so when x is 0, so this is 0. When x is 0, so we get no, that's not 0. So this is 0, this is 0. So 2y cubed is equal to 16. So y cubed is equals to 8. So y is 2. So 0, 2, we have that. So this is one answer. Then for the other part, so I'll just do it on this side. So when, for the other one, so when y is minus x over 2, so what do I have? So 2 bracket minus x over 2 cube, okay, minus 3x squared. You can substitute anyone you want, it's your choice. Then bracket minus x over 2 minus x3 is equal to 16, equal to, I just change that so that that is equal to 16. Okay, all right, so from here I just expand this to be 2, then minus x cubed over 8 minus 3x cubed, so that will be plus, then minus x cubed is equal to 16. All right, so from here just collect like that, so you can just press your calculator. So minus x cubed over 4 plus 3 x cubed minus x cubed is equal to 16, right? So I just do minus 1 by 4 minus 1 by 4 plus 3 minus 1. So that gives me let me see, that cancels. So just check again. Okay, there's 3 by 2 here. 3 by 2, 3 by 2. So I just check my 3 by 2. So 1 by 4 x cubed is equals to 16. So 1 by 4 x cubed, so this x cubed is equals to 64, so x is 4. Okay, so my coordinates, so when x is 4, so y is equals to minus x by 2. So what do? We substitute. So y is equals to minus 4 by 2, which is minus 2. So my coordinates are minus 2, comma, x first. So 4, comma, minus 2. So these are my coordinates. So I hope it makes sense. I hope it makes a lot of sense. All right, so now let's see this one and how to solve it. So this is identity. So we're to prove identity of sine 4x. So how do we prove sine 4x? All right, so we just look at, so we know this should be like an identity you should already know how to prove, but let's see. So we know sine, just use red, sine 2x is 2 sine x cos x. We know that. Okay, so it means sine 4x will be just, you're doubling inside, okay? You have to double the angle inside. So this is sine 2x cos 2x. That is sine 4x. So I just replace it there. So that will be, so from here, I can do 2 sine 2x is 2 sine x cos x cos 2x. Sine 2x is, so this is 4 sine x cos x cos 2x. And what is cos 2x? Cos 2x you should know. So we have to check the identity to use. You can see there is, they reduce it from 4x to no x. So cos 2x, we can use identity for cos squared. That's cos squared. So they don't need, so sine should not be there. So I just use cos squared x minus 1. So 4 sine x cos x bracket cos squared x minus 1. Okay, I think I got it. So you just expand only this inside. So 4 sine x cos cube x minus cos x. So this is my proof. That is my proof. All right. It's a little bit tricky, but they just try to make things a little bit difficult. All right. Now let's see. We're integrating this. So let's see how. So I always say whenever you are giving integration with limits, you should always use the calculator to know your answer. So 0 pi by 4 pi by 4, then cos, so cos x cube, okay, sine 4x sine 4x. So we should get this is what we should get. So just remember this answer, root 2. So this is our answer, root 2 plus 12 over 35. Even if your calculator does not give you surds, you should get decimal. So you just compare. So hence, whenever you see hence, it means use your answer for the previous one to solve this. So we know that we integrated this to be, we use identity, so 4 sine cos cube minus cos. So this is actually cos cube x. So this is what I proved earlier, which is 4, sorry, was it 4? That was so sine 4x. Okay, yeah, 4 sine x, then bracket 2 cos cube x minus cos x. I hope 4 sine x 2 cos cube, was it 2? Yeah, 2 cos cube x. I think I missed a 2 here, right? I think I missed a 2 here. This is 4. I think I missed a 2 here. This is 2. This is 2. This is 2. This is 2. Yeah, that's 2. Okay, yeah, that's 2 cos squared. All right, so that is what we are to prove. All right, so for now, let's see. So if I expand this will give me integral of 0 pi by 4. This will be cos. So cos to the power of 6 x. So 4 is here. 4 to the power of sine x minus this multiplying. So this will be cos to the power of 4. So I'm multiplying this by this, and 4 will be out here also, then sine x. Yeah, so this is what we have. So I can integrate it separately. Cos 6x sine x minus 4 cos 4x sine x with respect to x, with respect to x, with respect to x. All right, now, so 1 second, I just check again. Okay, I think this is 8. Okay, this is 8. So this is 8. All right, so be very careful to always check whenever you're solving. All right, so what do we do from here? So how do we integrate this? Now, if you're good with integration, you should know that they're actually differentiating something. But if you don't know, I will just show you what we should do. So let's say I want to integrate this, right? So let u be cos x. Okay, so du dx will be minus sine x. So dx will be du over minus sine x. So if I'm integrating that, so how does it come? So it comes like u to the power of 6 times sine x times dx is, so I'm trying to integrate this, okay? Dx is du over minus sine x. So this cancels, and when I integrate, this will be u7 over 7 du. Sorry, I need to integrate. I'm doing both at the same time. So that will be, so this cancels, so u7 over 7 plus c. So that means you have to differentiate this. So if you differentiate cos to the power of 7x, it will be 7 cos x. Then you differentiate cos, it becomes minus sine. So this will be minus 7 over 7. You just saw it here. Remember, there was still minus here. So then times 8. So I put 8 here. Then minus. Then similar thing. So we have, so this, if we integrate it, gives us minus cos to the power of 5x over 5. So that becomes plus 4 over 5 cos 5x. Okay, so this is what we have. My limits 0 to pi by 4. These are my limits. All right, don't be angry, it's messy, but you should understand what I'm trying to do. You know, we don't have much space here and we're managing the space. All right, so this is what I will have. Now I just need to substitute my limits. You can either do it with u or you can do it with that. So when you substitute your limits, you should get something like this. So I'll just put the first one. So minus 8 by 7, then cos to the power of 7 pi by 4 plus 4 by 5 cos 5 pi by 4, then minus, I'll just write the other bracket down, that is minus 8 over 7 cos to the power of 7 pi by 0, that's 0. So 0 plus 4 by 5 cos to the power of 5, 0. Okay, so this gives me, so cos pi by 4, so I'll just press cos pi by 4 is root 2. Okay, then to the power of 7, you get root 2 over 16. So minus 8 over 7 root 2 over 16. That's for the first one. Then so similar thing, cos pi by 4 is that to the power of 5, you get root 2 by 8. So plus 4 over 5 root 2 by 8 minus the other bracket. So remember, we are minusing with that. So if I'm cos 0 is 1, so this will be minus 8 over 7 plus 4 over 5. So from here, all we need to do is quadratic like terms. So we can just press our calculator, minus 8 by 7. If you have time, you can simplify and see. So minus 8 by 7 times square root of 2 over 16, okay, plus 4 root 2 divided by 40, then minus 8 by 5 plus 4 by 5. So that gives me roots. Let me see, root 2 over 28. Did I miss anything? So minus 8 by 7, 4 root 2 over 40 minus 8 root 16. Okay, then 8 by 7 plus 4 by 5. Okay, I hope I didn't miss anything. Let me just go. I suppose we already know the answer, right? Okay, 8 by 7. 8 by 7. Yeah, that's my answer. So this gives me root 2 plus 12 over 35. Now it's very important, whenever you have limits, always check your answers. Now you see I almost went wrong because I wrote 5 instead of 7. So this is my answer to the paper. All right, so now we're in partial fraction. So how do we do partial fraction? All right, so for partial fraction, you should know that, or if you remember how to do partial fraction, the denominator power is x squared, the numerator power is x squared, so this is improper. So first I need to use long division to divide to know my remainder. So when I expand that, I should get x squared plus 5a plus 9a squared. You should be able to see that mentally at year 13. Alright, so this is x squared plus 4ax plus 6a squared, right? So if I divide, this is 1, or we can even just minus them, it's fine. So same thing, x squared plus 5ax, this x is here, ax plus 9a squared. So this cancels, so that will give me minus ax then minus ax, right? Sorry, this is 6. Where did I get 9 from? So this is 6. This is 6a squared. So this cancels, this cancels. This is, so my fraction looks like this: minus ax over x plus 2a, then x plus 3a. This is how. So now for this, I need to solve using partial fraction. So that will be a over x plus 2a plus b over x plus 3a. So when I make common denominator, I get ax minus ax is equals to a bracket x plus 3a, then plus b bracket x plus 2a. So when x is minus 2a, so what do we get? So x is minus 2a, so this will be, so I substitute here, here, and here. So that gives me so that gives me 2a squared is equals to a bracket minus a. So my a is equals to minus my a will be, let me see what I'm, okay, minus 2a, right? So this should be plus. How did I get minus? So this becomes 2a. So this is my a. Then when b is equals to minus 3a, plus 3a. So I think we are done. So this will be 1 plus, so my a is 2a over x plus 2a minus 3a over x plus 3a. So this is my answer. I hope it makes sense. All right. Now, for part B, we were told to integrate this and give your answer in this form. So how do we integrate this? So we're integrating from minus a to a of 1 plus 2a over x plus 2a minus 3a over x plus 3a. So we're integrating this with respect to x. Alright, so what is the first thing we are going to do? So this is just direct integration. This is x plus 2a ln x plus 2a minus 3a ln x plus 3a. Okay, then I substitute my limit minus a to a. So now I'll just substitute my limit directly. So for a, this will be a plus 2a ln. You can put modulus for the ln, doesn't change, but whatever comes out to be positive. So ln, if I put a here, this becomes 3a, okay, minus 3a ln 4a. All right. Then for the other one, this becomes minus a plus 2a ln. So we're putting minus a, so ln a minus 3a ln 2a. So I'll just check, always check to make sure. So a plus 2a ln 3a minus 3a ln 4 minus, and minus here 2a ln a minus 3a. Okay, so we should just expand the bracket. So a plus 2a ln 3a minus 3a ln 4a plus a minus 2a ln a plus 3a ln 2a. So we just collect like terms now and see what we can get. So obviously a is common, so I can first take a out. So 1 plus 2 ln 3a minus 3 ln 4a plus 1 minus 2 ln a plus 3 ln 2a. So this gives me 2 plus, now I want to start doing some simplification here. So let's see how I can simplify this. So this will be, for these two, I can do, okay, let's see how we can simplify the ln. Okay, this will be, are there any like terms? 3, no like terms. So let's see how we can simplify this. Okay, let's see how we can simplify these numbers. So we can group, there's 2 here, there's 2 here, and okay, I think I can group them. So I will just regroup these 2 and these 2. So 2 ln 3a minus 2 ln a minus 3 ln 4a plus 3 ln 2a. Okay, so this becomes 2 plus 2 ln 3a over a minus, okay, I'll put plus, I'll write this first, plus 3 bracket ln 2a over 4a. I hope you understand what I did. I just, because there's 2 here, I grouped them to make ln. So a cancels a cancels a. So this is a 2 plus 2 ln 3 plus 3 ln 1 by 2, 4 over 2. So we are to give it in this form. Okay, so a 2 plus 2 ln 3 plus 3 ln plus 3 ln. Okay, we can just do the ln once. So this is ln. Now this is 3 squared, right? This is that squared. So I'll just take one ln. So 3 to the power of 2 times 1 over 2 to the power of 3. So a 2 plus ln 9 over 8. So this should be my answer. 2 plus ln 9 over 8. Yeah, that was very long. I think we can also simplify from here directly. Depends on how you look at the problem. All right. Okay, now we have number 10, which is this is rate of change. You actually did this, or you studied this in AS. Let's see. So this can come out in your AS paper also, because it's same concept, just something different. Okay, so they told us that the diagram shows a tank holding a water, and they also told us that the cube is that, what the depth of water, the water is poured inside, so water comes in, water leaks, water pours out from the hole, leaks out from the hole at a rate proportional. Now be very careful with this word proportional. So the total rate of water coming in and going out is 500 in 5,000 minus h squared, but it is proportional. You remember in GCSE or IGCSE, proportional, we have to put k. So whenever you see proportional, don't just write h, because it's not, it's something times the height. So we're doing in minus out. Okay, all right. So, and we know that the v by dt is dv by something times something over dt. So what do you think this should be? Obviously this should be dh. Okay, I'll just write that in different colors. So this is dh. That's how I normally remember it. Okay, all right. So we know that they gave us dv by dt to be 0.4, right? Then they also gave us the volume is 50 times 50 times h, which is 2,500 h. So the v by dh is 2500. Okay, so from here our dv dt, so I have two equations, take note. So this is equation 1, equation 2. All right, so what do I do from here? So we have dv by dt is equals to dv by dh, which is 2500 times dh over dt, right? So I have to substitute this there. So I have to substitute because we're trying to get dh. So I take this and I substitute here. All right, so that would be 2,500 dh over dt is equals to 5000 minus k h squared, right? Now they told me, so we have to find k somehow. So we can do dh by dt. Sorry, this is dh by dt. Okay, so dh by dt, so 2500 times 0.4 is equals to 5000 minus kh squared. My h is 20. So solve from here. So I'll just do the calculation here. I don't know why they didn't give more space for this. Anyway, maybe this. So anyway, I'm just explaining that there would have been an easier way. So 5000 minus 2500 times 0.4, okay, then divided by 20 squared, sorry, 20 squared, okay, 20 squared, so 10. So from here my k is 10. Okay, so from, I just substitute my value for k, so dh over dt is equals to 5000 minus 10 h squared over 2500, right? So we need to get that, so we just divide everything by 10. So I think that is how they got 500 minus h squared minus 2 divided by 250. So that is my answer. So I hope it makes sense. So be very careful when they talk about rate. You need to add k and find k. Alright, so I'm now told to, given that h is this, obviously you should know this is integration. So how do we solve this integration? So what we do here is we try to arrange it properly. If you don't know what to do in A, you can do B and just integrate. So dh 250, okay, I just take this down, so I just swap them. So that will be dh, so 250 comes here, 250 goes up, okay, those things just swap, over 500 minus h squared is equals to dt. So I'm integrating, right? So now the question is, how do I integrate the left hand side? So this is where we can use a technique. They hardly ask this kind of question, but so I can rewrite this as square root of 500 squared minus h squared dh minus integral of dt. I can rewrite that. So you should know the integration I want to use now, right? So if I integrate this, you check your MF19. If I integrate that, this integration, I think it was 1 by a squared minus x squared is 1 over 2a ln the modulus of x plus a plus x, a plus x. Shift that from here. So a plus x, a plus x. Pen is not writing. A plus x so that integration is, 1 second, I'll just write it. So a plus x over a minus x. This is the integration we're using here, because there's no way partial fraction obviously will not work here. All right, so we're going to see how we can use this. So that's why I'm squaring that, because 5 square root of 500 squared is the same thing as 500. So this will now be, so 250 is a constant, times 1 over 2a, so 2, then square root of 500, ln, people call it ln, doesn't matter, square root of 500 plus h over square root of 500 minus h, then is equals to t plus c. Because if I integrate, I have to put limit. They told me h is 0, t 0, right? So if I put h as 0, t is 0, so t is 0, so I need to find c. So my c will be h is 0, so ln, this will just be ln 1. ln 1 is 0, right? So c is 0. So I'm just substituting, so my t is just 250 times 1 over 2, then square root of 500 ln square root of 500 plus h square root of 500 minus h. So I just substitute my answer there. That will be 250 over 2 square root of 500 ln square root of 500 plus 20 over square root of 500 plus 20. 20 comes from here, okay? 20 comes from there. So you should just press your calculator. This will give 16.14 seconds. Let's see. So 1 by 2, or 250, 2 square root 500, then ln square root of 500, okay, fraction, square root of 500 minus 20, sorry, plus 20, then square root of 500 minus 20. Okay, 2 is supposed to be there, and put 2, so 2 is here. Yes, 16.14 seconds. So that is my answer to that question. So I hope it makes sense. Just the technique you need to use. Integration is a very tricky question, and hopefully you get it. Okay, this is vectors, and we're told to find MB, MC, and CMB. All right, so first thing we're going to do here is so MB is half of, because they told us is the midpoint, right? So it's half of AB. So this is half. And what is AB? B minus A. So B minus A will be B minus A. So 2 minus 4 is minus 2. Then 8, that is 10. 8 minus minus 2, this is 4. So this gives me minus 1, 5, 2. So this is MB. Then similarly, MC will be MB. So MB plus BC. So MB we already found, minus 1, 5, 2. minus 1, 5, 2, right, plus BCC minus B, so minus 2, so minus 4, 6, 0, so minus 8, 0, then that will give me 6, so this is 2, so this gives me minus 5, minus 3, 4. So this is my answer. So you should know the formula for angle. You should know if you don't. So this is cos theta is m. Be very careful here. It is the common point mc dot mb over modulus of mc, the modulus of mb. Okay, be very careful here. So mc dot mb, I'll just do the dot product. So that will give me dot product of mc and mb. So 5 minus 15, 1 times minus 1 times minus 5, 5 times, so this is 5 times minus 3, that's 15, minus 15. Then 2 times 4, that's 8 over, that's 8. Then we should get mc. So modulus of mc, that's square root of mc 1 plus 25 plus 4, then square root of, this is times or dot, multiplying them, then 25 plus 9 plus 16. Cos theta is, that's minus 2 over, I think that's correct, right? 5 minus 8 minus 15 plus 8, yeah, minus 2, then square root of 1 plus 25 plus 4, that's square root of 30 times 25 plus 9 plus 16, that's square root of 50. So that's the exact value of the cosine of the angle they are looking for. Now the last part of our quest in solving this past paper. I think this is a tricky one. So we're told to find the area of triangle ABC. So ABC. That's what we're finding. So we already found this angle. That's what we found now. So all we need to do is to find the actual distances of CB. So I'll just do CB. So CB or BC. So that's square root of BC. Did I do BC anyway? BC. Yeah, BC was so 4 squared is 16 plus 64 plus 4. So square root of 16 plus 64 plus 4. So that's 2 square root 1.1. Then we found MB. So this is root 30. This is also root 30. We found CM or MC. MC is did we find MC? No, let's find MC. So that's square root. Yeah, we found MC, right? MC is square root of 20. see square root of 20. Okay, all right, so we can just, the angle is the same, right? Because if we're using half AB sine C, then the angle of B, this angle and this angle, if you take the sine of them, is the same. But the trick here is to get the exact value. So to get the exact value, so I'm just doing 1 over 2 times half AB. So CM MB, CM times MB sine theta. Now it will be the same, right? Because they have a common angle. This is root 30. So half AB sine C, half AB sine C. So I'll just multiplying it by 2. So that is 2. So I think that is what we need to do. So how do we find the exact value of sine theta? So we know cos square theta plus sine square theta is 1. So this is the most tricky part of this question. So minus 2 over square root of 30 minus 2 over square root of 30 times square root of 50 squared plus s squared is equals to 1. So this gives me 1 minus, so s squared, s will be square root of 1 minus, so I just press that in calculator, minus 2 over square root of 30 times square root of 50. So that gives me, so when I square this, so minus root 15 over 75 squared. So s would be, so answer squared. Okay, answer squared is that, then 1 answer, 1 minus answer, 1 minus answer. So you get 3, 7. So s is 374 over 375. So this is s. Then we'll take square root, right? But we're not taking square root. So square root of that. So that is s. Okay. Now let's see how we can find the angle. So from here we can have 1 over 2. So 2 we cancel 2, so I don't have that again. So CM was square root of 30 times square root of 20 times square root of 374 over 375. Okay, now how do we simplify this? So 30 times 20, was it 20? This is 50. This is 50. So this is 50. This is 50. Okay, so this will be square root of 1500 times square root of 374 over 375 square root. Okay, we need to give exact answer. Square root of 374 does not have. So the root of 375 is 5 root 5. So this is 1. So 374 over 5 root 15 times, then square root of 1500 is 10 root 15, right? So now this means this can cancel this can cancel this. So my answer is 2, this is root here, root 374. So that is my answer. So I hope it makes sense to you what we have done. So I'll just go from beginning again, and we can see what we have solved. So the first question, this is for now the marking scheme until it comes out, then I will verify to check how many I got. Then we have question 2, which is on logarithms. We solved it, we checked there. This is for sure correct because you can use calculator to verify your answer. And we had complex number. We had also, this is called integration. Then we have algebra. We had graphs. We had differentiation. Then we found the coordinates of the normal. Is it normal or, yeah, normal to the curve, which is normal. Then we prove the identity of sine 4x in a different way. Then we integrated. Then we did partial fraction. Then we also did integration again. We did rate of change. Then we integrated again, or differential equation. Then we solve vectors. This is a tricky one. The last part is a tricky one. So I hope it makes sense to you, and make sure you like and share this video or subscribe to my channel. And I'm also coming with paper 1 for those of you in AS. Alright guys, take care of yourself and bye.